Hi, I'm Todd Collins with AE Building System. This is Bill Lucas with
GB3 Energy.
And we're going to talk a little bit about ADUs today. This is Bill's ADU.
So after helping my neighbor build his ADU and doing all the mechanicals here and finding out how much rent he could get, I decided that this was a good idea to do. But I wanted to use the experience that I have building zero energy homes over the past 30 plus years and do this, because I'm in a 1904 brick structure that is certainly not zero energy by any means. But this one will be zero energy, and in fact, I'll end up with 12 kW of solar on this, which will now backfeed my house. So I'm able to electrify the heating and hot water in my house as well, and that system will be a little bit small for it, but we'll see if I can maybe tighten up my house. So I've done 24 on center framing. Everything is stacked, and the windows are, if you notice, they're all placed between the studs, so I don't need extra lumber, so I don't have extra studs in there. The 24-inch layout continues on all sides, and the windows are sized to fit between those, so I only have one jack stud and one, my main stud is my king stud that goes all the way up. So we'll see that on the inside. We have Alpen high performance triple pane, well, it's not triple pane, it's triple layer glass with argon fill that A&E Building Solutions provided for me. I purchased them. And this is not their super hot shot model of window, but still twice the performance of any Energy Star window that you can get.
About a 0.1718.
Yeah, they're right about there. I have a pretty shallow pitched roof. It's a 412 roof pitch. The underneath vaulted part is a 212. I have an energy heel that from the point right on the top plate all the way up is, I'll get a full 22 inches of dense packed cellulose for an R value of 60 at minimum at the corner. But I'm doing something a little bit interesting that I'll show you in a second. But the reason my roof pitch is so low, we're facing kind of, Golden's a little goofy, so south is here, but I'm putting a full solar array on both the south and the north side of my roof. People say you can't put solar on the north, but on a shallow pitch, I can still produce 85% of the power that I can in a perfect south orientation. So that, you know, I would be limited to maybe a 6K system here, but I can get 11K by mirroring this on the other side. So there's a couple panels that aren't producing 100%, but I'm getting 85%. And that allows me to really make this home net zero by just adding more solar. So the fact that you have a north-facing roof is not such a big deal, or a flat roof is great. Flat produces very well with solar.
So Bill, I noticed that you're using 2x4s instead of 2x6s.
So I'm a big fan of thermally broken envelopes. You need to break that thermal conduit that the stud provides from the inside to the outside. So one approach is to put mineral fiber, some sort of exterior insulation on. In fact, a really bomber building assembly is to put all your insulation on the exterior. Here, because of how this lines up with the siding on the outside, what I decided to do instead is a double stud wall. So what you're seeing now is just the first exterior load-bearing wall. I'm working on some things here, and then I'll have an 1.5 inch gap, and then another 2x4 wall. So I'll have a total of 8.5 inches. So I'm gonna end up with an R40 plus dense packed cellulose wall.
Super
here.
cool.
What I'm using here is I'm using an expanded polystyrene, and this is as glow as it gets compared with extruded polystyrene and polyiso. This stuff is, you can get it in higher densities. Most people think of the white cooler foam as being very soft. You can get this, you just call a local manufacturer and say, hey, I want some type 16 or some type 10 or whatever it is. And this stuff is 2 pounds per square foot density, or per cubic foot density. So this is, you can walk on this. And in fact, that's what I will have here. Because I want to break my thermal my thermal bridges, not only in the attic, but on the walls and the floor. I don't want the heat to escape through every single floor joist I have. I'm putting 1.5 inches of very dense foam board, but as environmentally responsible as we can get down.
It's a water-blown agent that, so it's a much lower GWP product.
Yeah, they're not using pentane or some crazy chlorofluorocarbon to blow this. And then I will put my beetle kill floor, my blue stained pine floor, will float on top of this. But this is hard. It's just like wood, so I will nail through this into the subfloor. So another thing, if you're using spray foam, you can do a non-ventilated roof. Because I'm not using spray foam, I'm using a borate formula cellulose, which I like more than fiberglass, although fiberglass can work very well, but it's much higher in embodied energy. They have to melt that glass. For cellulose, they grind up old cardboard and newspapers and whatnot. But I want to get a full dense pack of insulation, both in my walls, but also my ceiling. Now, what I've done is I've taken, you can see I've got a furring channel that's 1.5 inches down from the roof deck. And what I will have, and you can see in these channels that I've already started on, I will have 1.5 inches ventilated channel that goes from my soffit vent all the way up to my ridge. And this entire structure will be airtight before I ever add insulation and drywall. Typically, you have to have drywall before you can do a blower door. What I will do once this is up, I will actually spray something called Energy Complete or Eco Seal, but it's basically a very thin elastomeric paint that will seal every crack. Aero barrier, there are other techniques of doing this, but I will be able to blower door test this structure before I ever do any insulation, bury anything, so I can make it absolutely bomber tight, so I can get a really, really low air exchange per hour. Now, of course, I have to have a ventilation system as well, and there are some cool new ventilation products on the market for very small structures like this. And so I'm looking at the Lunos system for this particular house.
So Bill, you've got balloons on these, and I know what they're for, but it seems like you shouldn't have gotten balloons because you're at about the same elevation as where these Alpine windows are manufactured. Typically they use these when they're going up to Leadville, for example, 10,000 feet in elevation. They're really to manage the barometric pressure so that the actual window itself doesn't blow up on the way. And it will actually blow up if it's sealed.
You know what's interesting about the balloons, Todd? Here, I can step over here. I noticed that they will vary in volume significantly based on the temperature outside. And if it's warm outside, they will get completely full, and if it's cold, they will shrink. And so I think you seal them ultimately when you're at your happy medium, because you don't want the window to suck in and you don't want it to bulge. And you're right, we probably could get by without them.
60 degrees here in the front range, 50, 60 degrees is a perfect temperature to actually clip those off and and crimp them.
Good to know, because this is a cold day and they're pretty flaccid, but there's still some air there.
So Bill,
you
went pretty high performance. I mean, Zero Energy's pretty solid, double stud walls, high performance windows, a whole bit. What caused you to choose to go that path?
I think it's the right thing to do. My father-in-law is a little bit more conservative. He's a little old school, California Marine, and he keeps sending me YouTube videos about climate change. You know, maybe the science not being agreed upon, no consensus yet. And so I try to look up things to share with him. And the other day I was looking up the carbon level in our atmosphere. And we've known this, who are in the environmental business for the past 20 years. It keeps rising. We're at 410 parts per million carbon dioxide in our atmosphere right now. We haven't been above 280 in the last 800,000 years. As carbon goes up, CO2 goes up, temperature goes up, sea level goes up accordingly. It's just a graph. You can see it from ice sheets and samples that have been taken for that long. I'm very, very concerned that unless we move towards a carbon neutral world where, and natural gas and coal, although natural gas is much better than coal for carbon output, it's still got a carbon footprint associated with it. You can get a 100% efficient furnace or water heater, but you're still putting out carbon that's been buried for millions of years. So we need to be using electricity from renewables. And I think even our utility companies, realize that. But there's also an economic reason for it. So it's not just doing the right thing, it's also, it saves you money. Every building around here, and we switch to efficient electric heating. Or if your house is incredibly efficient, like a passive house, you may just need an electric baseboard. And a couple thousand BTUs is enough to keep that super insulated space warm.
Light some candles.
Light some candles. I mean, you're talking super low BTUs. So the load on this is about 5,000 BTUs. And I think that's very
Holy cow.
conservative. I don't think it'll be above like 3 personally.
Per 700 square feet ish.
It's not that much, but yeah, it's just, so you build tight, and I don't need a massive system here, and it's going to be super comfortable. It'll be incredibly healthy with the ventilation system. So why would you spend as much money as we spend on our buildings and not do that? We want them to be, the difference between building green and not, the perception is it costs 20% more. The reality is it costs, to build something really green might cost the same, especially if you're downsizing your equipment and you've thought about it all up front. To retrofit a house 15 years from now in 2035, that gets to be more expensive now. We have to think about how are we going to get these line sets for our refrigerant here and there, and the lower your load, the more options you have. Like a candle. You can heat it with a candle if you need to.
A hairdryer.
There's a survivability about a really, really efficient structure.
I have a client that uses his clothes dryer
Sure.
on occasion to heat his house.
Yeah. It's so for me, yes, it's what I do for a living, but why I do what I do for a living is because of what I believe. And that's why I drive a hybrid, and we're working towards getting an electric car. That's why I'm retrofitting my house. And we make decisions all the time that people are like, well, it's too expensive. What's the expense of a vacation to Arches National Park? Why would you do that? Well, it's a great thing to do. So is having a low carbon lifestyle. And you can still drive, you can still be warm and comfortable, you can still cook on your induction stove, you can still have a cool fireplace without a fire. It can be a humidifier fireplace now. They're really cool water vapor fireplaces. They look amazing. It looks like flames. And there's so many reasons to try to be part of the solution. And I think it also brings me a little bit of, I don't know. I mean, it's just what I want to do. I got one life to live. I'm not going to be here forever. My kids hopefully will be here longer than I am, and I want to try to leave something better for them. So I do it in my own small way.